Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in beautiful Glen Ellen, Illinois. And this video today is going to take a look at three separate problems. This is basically an activity homework assignment that I'm showing the solutions to. We're going to take a look at Chapter 2 stuff, which is like C out and just kind of getting the basics going. I can't remember if Chapter 2 is also C in, but Chapter 3, between Chapters 2 and Chapter 3. So C out for output, C in for input, and then we're going to take our output and we're going to use the IO manip library in order to format the data with 2 decimal points and always show the decimal point and things like that, or two digits after the decimal point and so forth and so on. And so here is our first problem. So I went ahead and took the problem and I kind of modified it slightly just to kind of get us kind of going here. We're going to need the IO manip library. We're going to need the IO stream library. And then I went ahead, we have our 3 variables: quantity, item price, and total bill. And what we're doing is just, this is a really complicated program that does one multiplication. Take the quantity, multiply it by the item price, and there's your total bill, right? If I buy 3 cans of tomato soup at 50 cents a piece at the Aldi, 3 times 50 cents is $1.50. So that's where we're going with this kind of stuff. So I'm going to modify some of this. I already did. Again, I'm going to try to personally get you guys to stop using namespace STD for everything that you do, because again, the more professional way is to put the STD : in front of everything. So that's just one of the changes that I've made. Another one here is that there's no reason not to use double. I mean, we're living in the future. This is 2021, almost moving on to 2022 already. My goodness, where is the time going? But floating point is great for gaming and things that need fast computations, and you don't necessarily mind if the calculation is off by a little bit. But we care. Most of the world cares that the calculation for money or something is going to be off. You don't want that. You want that dollar amount to come out correct. So double is the better way to do things here, because double is a 64-bit representation. So you get much more precision on this than you do on the float side. And so we'll see that as we move forward. Another thing here is the way this prompt is. Please input the number of items bought, and then it's an end line. So the input goes underneath. I personally don't like that. I think most of the world doesn't like that, so I'm just going to go ahead and do something like that. Please input the number of items bought, and then the cursor is going to stay there while we're waiting for the user input. And we'll do that here right now. Fill in the user statement that brings in the quantity. So that is the CIN. And you say, okay, I want to get the quantity. And notice how the chevrons, I know it's a fancy name for the little arrows, this string is going into this stream. So that this is going to be printed using cout. The user is going to input information into the quantity variable. That's kind of how you think of how the arrows go. And here we go. So please input the number of items bought. Again, notice where the prompt is now, or the little flashing cursor. I want 90 of them. Excuse me. And we'll fix that up as we go. So now, okay, fill in the prompt to ask for the price. Please input the price for each item. And I like to put, whatever. Again, coming back, this is just maybe my OCD, but over the years, working with video games and working with things like this, that the presentation is just as important as anything else when it comes to writing your programs and creating stuff that end users are going to use. Fill in the input statement, so CIN into item price. Excuse me, I don't know what's going on. Need a drink. Excuse me. Okay, so then there is my process and calculation stage. Or no, I don't know where, wait, I don't know where this is. I don't know why that ended up down there. Sorry about that. But now, yeah, there is my givens and input stage. So now I have my 2 inputs. What is my quantity? What is my item price? That is all I need. This total bill does not belong here because that is not an input. That's a calculation. And so that's another thing to fix up that I feel like needs to be fixed up here, is that the way the program was written, in the workbook is more of a C-based way of doing things, where the names or the variables are set up at the front of the function, and I don't know if that was conventional. I missed the C days. I do not know too much about how C is formatted that way. Don't know if it's conventional or required to put the variables up front. But in a more modern world, more modern environment now, we only declare the variables when we have to and define them when we have to. And so, of course, the total bill is going to be equal to the quantity. Oops, just got to spell it right. That's the hard part. Quantity times the item price. So all of that input, there's a lot going on in that input stage. And there's a lot going on up here. But now the calculation stage was very simple. And so coming back to this, there's no way to put this on one line, kind of like with this, where you declare and define at the same time. When you're dealing with inputs, there's no way to do that. So usually it's 3 lines of code to do one input, because you got to set up the variable, you got to print out the cursor, and then you have to do the input. Where in Python it's all done in one line of code. Okay, so let's see. We filled in the total bill. That's great. And now the output stage is going ahead and setting all this up. Here's my formatted output. So I always get the decimal point, and I always get 2 digits after, because on a receipt you always want to see that, right? If the dollar amount ended up being 12, you never see 12. You see 12.00, and that's what this is doing here. And so the final step here is to just do a cout. The total cost, or something like that, of codes. Total cost is, and then I print out the total bill. And then an end line. Here I do the end line, so that when the program ends, all the system pause doesn't come up on the same line. That should do it. Enter the number of items bought, 95. How much are they a piece? 64 cents. So then my total cost is $60.80. And so one more time here, just to say, like, if I bought 100 of something at $1.99, it comes out at $199.00. If I forget this line of code and get rid of my formatting, like I was explaining before, now I can show it. 100 items at 99 cents a piece. You can see it's 99. There's no dot. There's no .00. So this is a good way to use formatting to get the job done. Okay, so this covers problem 1, and the next 2 problems are just going to be different variations, just kind of repetition in a way to get you used to this if this is brand new to you. So here, this again, coming back, this is my input stage right there. Here is my calculation and my process stage. Here's my output stage, and then here is my cleanup stage. Okay, so let's move on to problem 2, and let's take a look at that. So here is that second example. You can see there's quite a bit kind of wrong here, which we'll fix up. Let me bring up the error list so we can, oops, what did I do with it? Oops, where is it going? There it goes. So there's a lot going on here. Coming back, remember that I want to use double for all of this and not float. You're not going to get in trouble for not using double, or if you don't watch this video or anything like that. But I'm just trying to show you better practices than what I see in this textbook. Here's my cleanup stage that I'm fixing up. I'm just kind of breaking things up, right? So here is my cleanup stage. Here's my output. Here's my input. Where my calculation is somewhere in between. I personally like to put, this just was beaten into me and out in the real world, was to put each variable on its own line. So in case you needed extra comments or anything like that, it doesn't get lost between all the commas and all that. Go, oh, I didn't even see that there. You very clearly see it when you do this. I'm going to call this hypotenuse. There's no reason not to spell out the whole thing. Again, in my experience over the years, you write the code one time on one day, and then you look at it for the next 6 to 24 months or even more. Wouldn't, just spend that extra half a second or second and type the stuff out so you're not questioning yourself later on. And now I'm going to put in the SD colon for everything. There's my C in, there's my end line. There's a lot of end lines here, a lot of C outs. Let's just see where we get to with this. Oops, oh, hypotenuse. Did I not spell hypotenuse? Oh, uninitialized. We'll fix this in a minute, but just to get this thing to compile and run, I just want to show you it's working before we get moving here. Okay, please input the value of the two sides. Okay. And so here is our, we're working on our, now this is going to be our calculation stage, but we're working on our input stage to start with. And so please input the value of the two sides. First off, colon space without any end line. But I personally do not like this, like, please, like, what do you mean, space separated? Like, there's, as much as you think nobody could get this wrong, people can get this wrong all the time. So please input the value of the two sides. How about please input the value of A? And then I input into A. And then I ask, hey, how about you tell me all about B? And you do that. And now the user knows exactly what to do. Please input the value of A, 9. Value of B, 12. And there's my 9, there's my 12, and there's my 0. We haven't fixed it yet. But you get that point. And what's interesting, though, you get the same result. If I put 9 space 12 and hit enter, you can see that the sides of the right triangle are 9 and 12. So, like, you can do the same behavior as you just did before because of the way that the buffering works and the CN operation works in C++. So you can do things. It throws things off a bit, but you still can do the same behavior as what they were doing there a minute ago. So I've got my A and I've got my B. My inputs are done. My input stage is complete. And so now, as you can imagine, we're trying to do the hypotenuse, which is the square root of A squared plus B squared. So I'm just going to show you using the CMath library functions how to do it, and then, out in the real world, how would we do this for real? So what I would say is, if I wanted A squared, I would say I want the power function, and I want to use A, and I want to take that to the second power, A squared. And then I would do the same thing for B squared. Make sure there we go, put that. And then for here, this is the square root of A squared plus B squared. Okay, and so there we go. And so now if I put a 3, 4, 5 triangle into this thing should work. 3, 4, and then now the hypotenuse is 5. Yes, that's exactly what I'm expecting to see. And so now, that's what the CMath library is all about. The power function takes 2 parameters, x to the y or a to the b, however you want to think about it, a squared. This is b squared. And the square root function just takes one value and square roots it. So, 9 plus 16, 25. What's the square root of 25? It's 5. And so that was just to show you how the library functions work. But this power function is a very powerful tool. It's a very general use tool. It can calculate a squared, obviously, but it can also calculate 1.72 to the 9.7 power, all sorts of crazy things that you might do in, like calculus, or you might do out in engineering, but you're not going to necessarily do that here for it's a lot different than using this here for just to multiply a times a. Wouldn't you rather just, how much simpler and how much less code and how much more efficient is this a times a, right? Because it's one multiplication versus who knows what this power function is doing under the hood. Because again, it's got a lot of fancy bells and whistles for complicated stuff, but not necessarily for the stuff we need. And so I can reduce this down to something like that. Double hypotenuse equals the square root of a squared plus b squared. And I added the extra parentheses just for clarity. I highly recommend, again, like everything else, you write the code one time, you stare at it for months. Or maybe you write it and then you got to come back in a year or two and look at this code and fix a bug or anything. And you want to make sure that you can understand what you're doing and what you're looking at and comment as you go and things like that, so that when you come back, and I had that happen to me once or twice, I had to come back a year or two later, and of course in the moment when I was writing that code I knew everything I was dealing with, but when I come back a year later, it takes time to bring your brain back up to speed on what you were doing then. Or if it's other people coding, you want to help your buddies out, and you want to make sure they help you out too. So there's my calculation stage, and then the print stage is already done here, the output stage. It's just a matter of filling in the gaps and saying, oh, I want that fixed decimal point, and I want to set the precision to 2, so that instead of just printing out like 3, 4, 5, or just 5, it'll print out 5.00. I'm an STD here. Okay. Come on. Oops. What did I do? Oh, the reason for this is because, and this is, oh, I was like, why isn't it running? Namespace STD has no member set precision, but it does. It has fixed. But where is this set precision? It's in the IO_manip library. So I have to make sure I include IO_manip. And you just get used to this kind of stuff. And it does suck. If, you know, I got to admit that you can't just right click on it and go, include that for me, like you can for other languages, or at least it had, you know, maybe it does now, but it didn't in the past. And so you just have to get used to what functions are found in which libraries. And if you're going across different compilers, you have to kind of get used to that too, because different compilers implement these things slightly differently. And some of you may already notice that with the way I do things here in Visual Studio and the way you're doing things with your compiler at home. Anyway, so now we can finally finish up here. Say, what is my value of A? 3. What is my value of B? 4. And then 5.00 comes out. And there's my 3.00, 4.00. So we can give it a little more going here. So it gives me everything to 2 decimal places. And of course, you can change that if you see fit here, set precision 2. So 6.4 and 5.8 gives me a hypotenuse of 8.64. Okay, so that's part 2. That's pretty much it. And so part 3 is going to be one more thing. We're going to start with a word problem and work our way down. We're not going to be given code to start this time. We're going to be just given English words and expected to come up with a candidate solution program that solves that problem. And here it is. Write a program that will read in 3 grades from the user from the keyboard and will print the average to 2 decimal places of those grades to the screen. It should include good prompts labeled output. Good prompts, of course. So we're going to need our includes. I know IOStream, because if I'm doing input-output, I need IOStream. I see the 2 decimal places, so I'm going to include IO_manip. And there's no penalty to include. Well, there's no real penalty at this stage to have includes that you're not technically using. Like if you wanted to include CMath here, even though we're not going to be using it, you can go ahead and do that. It's just for larger and larger projects that have all these linkages across these different files. We're talking hundreds or thousands of files all working together. It does slow the process down, the compile and link stage, when you go ahead and include things that you're not technically or not really using. Just be careful with that. And so let me just get going here with my main function. And my system pause, and my return. Okay, so there's my cleanup stage, and now I just need everything else here. So I need 3 grades from the keyboard. That's my input. I'm going to process that by calculating the average. That's my process. And then I'm going to output the average. That's my output. And so I think we're good to go here with just doing this sort of stuff. So I'm going to create 3 variables. I'm just going to call them A, B, and C here. Double. Okay, so now I'm going to ask the user for inputs. So I'm going to go stdcout. Enter the first grade. And some of you might think that's like a comment. Like my son is in first grade and he just entered the first grade. Enter the second grade. No, he's in first grade. No, this just means please enter the first grade of 3, of course. Yes, stupid dad humor. It's all I've got these days, especially now that I'm sitting in my house. He's at least at school. Is good. Gets that experience that he didn't get in kindergarten. All right, enter the first grade, enter the second grade, enter the third grade. And you want to make sure that the inputs are going to the correct places, because you'll get terrible results if you accidentally C into A twice and you forget to C into C or something like that. So here's A, here's B, here's C. We are good to go. Let's just test this out, make sure everything I've typed now syntactically correct. Okay, cool. Enter the first grade 8, second grade 4, third grade 1. Okay, and so we have something going for us now. So our input in given stage is complete. We have our 3 grades. It's just a matter now of figuring out the average. So PEMDAS rules apply here, parentheses, exponentials, and then the multiplication, division, and modulus operations, followed by addition and subtraction. So A plus B plus C, that gives me a summation, and I want to divide that by 3. And so now here, take this into a thinking here. A is a double, B is a double, C is a double. So when I add all of this together, I get a double on this end of this. And just to be on the safe side, if I want to change this later and change these doubles to ints and things like that, I want to make sure, at least for now, or at least for whatever, that I get I don't have an integer division here. And right now we won't have that issue because we have a double divided by int. 3 is an int. But I want to make sure again, and this is just thinking to your future career, that never say you'll never come back and you're never going to come back and change your code around, because there's a good chance that you might, especially if you're working on a large project. But you want to make sure that no matter what, I'm going to divide by a double so that there's no accidental integer division. So double divided by double will get me a double. And so like if A was an int, a B was an int, and C was an int, now integer divided by double will get me a double, which will get me the correct precision. But if it was integer divided by integer, then I'll lose that precision. So what I'm saying here is, like the number 3, that's an integer. 3.0 is treated by the compiler as a double, and 3.0f is treated by the compiler as a floating point quantity here, as a value. So just keep that in mind as we're moving forwards with everything in your career, not just in C++, but any language. Like, you should always know the data types that you're dealing with to make sure that whatever's running your program, interpreter or compiler or whatever, is not mangling and changing your values just slightly to just give you, poor results. Okay, so that's it for calculation stage. And so now the final step here is just the output of this. And because we want the 2 decimal places, we want to make sure we use some fixed decimal and set precision to 2 before we go ahead here. And then we see out and we say, okay, the average is, and then your average, and then an end line. And so here's my input stage, here's my calculation stage, here's my output stage, here's my cleanup, and let's see what happens. So because of the forced precision, if I put 99, 99, 99, it comes out as 99.00, which is what I'm expecting to see. And so now whatever, and there's no sanity check, so if I accidentally put 954 instead of 95.4, you end up with some weird results. My average should not be 380. Should always sanity check your inputs and sanity check your outputs. Garbage in, garbage out, and there's no checks here. But at the end of the day, this looks like it gets the job done. It's really complicated. There's a lot of code here just to do a couple additions and a division, but that's how a lot of programming ends up being. Okay, so that covers all 3 problems I wanted to cover for this assignment, this activity. So as always, if you have any questions, if I misspoke, if just something isn't clear to you, then please email me at swardb@cod.edu, or you can always get a hold of me here on the comment section, in the comment section here on YouTube. So next chapter stuff, we have a homework assignment for you guys. Those of you who are not my students probably will not see that video, but those of you who are my students will. And then we're ready to move on to chapter 4 stuff, if statements, selection statements, if, else, switch statements, switch is allowed in C++. You'll see those kind of details next. So thanks for sticking it out with me as always. I hope you guys have a great day, and hope you learned something, and I hope to see you in another video. Take care. See you then.